This is part 2 of the video introduction to Activity 3.4. We'll look at a visual proof of the quadratic formula. We'll use our full set of algebra pieces. You might have noticed that in our previous work, our quadratic functions factored and the corresponding x-intercepts and intersection points had integers or rational number x values. Of course, there are many cases where these x values are not integers or rational numbers. For functions such as y equals x squared minus 2, we can find the x-intercepts by solving an equation such as x squared minus 2 equals 0, as we previously did. But to solve quadratic equations such as x squared plus 2x minus 1 equal to 0, we need a more powerful technique. We'll start with a general quadratic equation and manipulate the equation until we have a square left side equal to a number right side. Then we'll take square roots of both sides and we'll derive the quadratic formula. And we can use this to solve any quadratic equation that has solutions. And our technique is called completing the square. We'll start with our quadratic equation, ax squared plus bx plus c equals to 0. Importantly, a is not 0. And our coefficients aren't fixed, and our following diagrams are only abstract representative figures. Our goal will be to make a square left side and a number right side. We'll start with a representative pile of algebra pieces. Ax squared, some black x squares, bx, some x strips, c, some black or red tiles equal to 0. Completing the square is simpler with only one black x square. So we'll divide everything by a, which we can do because a is not 0. And unlike all the rest of the representative figures, we really do have just one black x square here. Our symbolic equation, when it's simplified, will then be x squared plus b over ax plus c over a equal to 0. For the algebra pieces, it's easier if we move the c over a to the right side. And we'll do that symbolically as well. Now we'll divide our x strips, b over a x strips, into two equal piles. Those are each sized b over 2a. And we'll form a partial square on the left. When we add the edges so far, along the top we have x plus b over 2a, and down the left we have x plus b over 2a. Now we'll complete our square. The dimensions of this region 4 hole that we had here are b over 2a times b over 2a. So we'll add b over 2a squared to each side, and we'll do that symbolically as well. The symbolic formula looks really complicated, but we can use our algebra piecework to factor. Our factors are x plus b over 2a times x plus b over 2a. So our symbolic equation factors to x plus b over 2a quantity squared, which makes sense when you look back at our original equation. On the right, these are just numbers, so we can add the fractions and we get b squared minus 4ac over quantity 2a squared. Since the left side of our equation is a square and the right side is a number, we can take the square root of both sides. So we have the square root of quantity x plus b over 2a quantity squared equal to plus or minus the square root of the fraction b squared minus 4ac over quantity 2a squared. The square roots can go over the numerator and the denominator separately, And this simplifies to plus or minus the square root of b squared minus 4ac over 2a. We take the square root of quantity 2a squared. Now we have x plus b over 2a equal to plus or minus the square root of b squared minus 4ac over 2a. We can subtract b over 2a from both sides, and then we can combine our fractions which have a common denominator of 2a, and we get x equals minus b plus or minus the square root of b squared minus 4ac over 2a. This is our quadratic formula. Let's look at the quadratic formula in our previous examples. When we have x squared equal to 4, we see that a is 1, b is 0, and c is negative 4. When we put these into the quadratic formula, we get plus or minus 2. That checks. When we look at our second example, x squared equals to 2, again we have a equals 1, b equals 0, and here c equals negative 2. When we run that through the quadratic formula, again we get plus or minus the square root of 2. That checks. Our third example was quantity x minus 1 squared equals to 2. First we must multiply that out, and we have x squared minus 2x plus 1 equals to 2. When everything is set equal to 0, that's x squared minus 2x minus 1 equals 0. So a is 1, b is minus 2, and c is negative 1. Because b is negative, we carefully put parentheses around our b. So we have negative quantity negative 2 for negative b plus or minus quantity negative 2 squared minus 4 times a, 1 times c, negative 1. So negative negative 2, 2 plus or minus the square root of 4 plus 4, 2 plus or minus the square root of 8 over 2. 8 is 4 times 2, so we can pull 2 out, and we get 2 plus or minus 2 times the square root of 2 over 2, which is 2 over 2 plus or minus 2 times the square root of 2 over 2, which simplifies to 1 plus or minus the square root of 2, which is what we had before. In part 3 of the video Introduction to Activity 3.4, we'll look at turning point form.